Hi there. So today I'm going to be talking to you about trigonometry. I'll be giving you an overview of why it's important, some of the more important formulas, and a few examples to work on. So first of all, in case you're wondering, what exactly is trigonometry? Well, simply put, it is the branch of mathematics that studies the relationship between the sides and the angles of triangles. And did you know, trigonometry was first discovered more than 2,000 years ago in Egypt and Babylonia. So why is trigonometry important? Well, trigonometry is an important part of mathematics, and it has countless applications in real life. For example, you can use trigonometry to calculate the height of a mountain, tower, or any other large object. You can determine the height of tides or the distance to the shore from some point in the sea. You could also calculate the distance between celestial bodies, although these calculations would be a lot more complicated. And there are many more applications for trigonometry. So, let's start off with the basics. The triangle you see here is a right-angled triangle. And as per Pythagoras' theorem, which only applies to right-angled triangles, we can say that a squared plus b squared is equal to c squared. Over here we see some of the more fundamental formulas of trigonometry. So sine of angle A would be equal to the opposite length divided by the hypotenuse length, which is equal to b divided by c. The cosine of angle A would be equal to the adjacent length divided by the hypotenuse length, which is equal to a divided by c. And the tangent of angle A would be equal to the opposite length divided by the adjacent length, which is equal to b divided by a. Now let's look at two very special triangles. The two triangles you see here are special because they are able to work out the trigonometric values of the angles without having to use any complex formulas or calculators. So looking at triangle A, we can say that cosine of 60 degrees would be equal to the adjacent side divided by the hypotenuse side, which gives us 1 divided by 2, which is 0.5. And looking at triangle B, we can say that sine of 45 degrees is equal to the opposite side divided by the hypotenuse, which would be equal to 1 divided by square root 2. And this applies to all other angles within the triangles. Now remembering these two triangles will help you calculate the trigonometric values of these common angles without having to use your calculators. And this is something really convenient. And here we see more formulas for right-angled triangles. The secant of angle A would be equal to 1 divided by cosine A. The cosecant for angle A would be equal to 1 divided by sine A. And the cotangent of angle A would be equal to 1 divided by tangent A. Please note that although the notation used is 1 divided by either cosine, sine, or tangent, it doesn't mean that the secant or the cosecant or the cotangent is equal to cosine inverse, sine inverse, or tangent inverse of A. So what about triangles that aren't right-angled? Well, in this case, we would need to apply the sine rule and the cosine rule. The two rules are shown below the diagram of the triangle. So now for practical applications, read the question and try to figure out what is the horizontal distance between the bear and the tower. Using the basic trigonometric formula, we can determine that the distance of the bear from the tower is equal to 160 meters divided by the tangent of 60 degrees. And this gives us a value of 92.38 meters. Take a look at this question and try to determine the value of x. So for this question, since the triangle in question isn't a right-angled triangle, we cannot use the basic trigonometric formulas. We have to use either the sine or the cosine rule. And since using the sine rule is easier, we have decided to use that. And the value of x that we've gotten should have been 2,581 meters. Thank you for watching the video. I hope you learned something new, and hopefully your understanding of trigonometry has improved. Goodbye.